In the previous lessons, we learned how to calculate Q equal to MCAT, and Q is heat, and the unit for heat is joule. And Q, or heat, is equal to mass times specific heat capacity for that particular substance. So different substance will have different C times the delta T, and delta is always final minus initial. In order to use this equation, we need to know the unit for each of the variable. Well, Q is heat, and heat is measured in joule. And then M is your mass, which is in grams. And C is your specific heat capacity, which is joule over grams times Celsius. So therefore, this T right here must be in Celsius. And in the process, we also learn that when Q is negative, we know that it is loss in energy. And when Q is positive, it is gaining energy. So it's important to understand if Q is going to be positive or negative based on the problem. And one last thing that we are going to apply in this lesson is that when we have a loss in energy, the amount of energy loss is equal to the amount of energy being gained. That's why we have negative Q equal to positive Q. Now let's apply these two concepts to solve some problem. Let's try another problem. A sample of lead, its specific heat is 0.138 joule, again over gram times Celsius. Release 2,500 joules when it cooled from 150 degrees Celsius to 20 degrees Celsius. What is the mass of the sample in grams? So this is a hypothetical problem, okay? And again, we are using the same equation again, Q equal to MCAT. So Q is equal to MC delta T. And if we look at this problem, we know that we are using the equation Q equal to MCAT. In this case, we know the specific heat, that will be your C right there, and release 2,500 joule, that would be your what? That would be what? Your Q right there. That's why it's important to memorize the unit for each variable. And lastly, we have a delta T. So again, from, that would be your initial, and then to, that would be your final. And notice how the final values is smaller than your initial. And that's why it's important to visualize what's happening in the problem rather than memorize the pattern. Rather than try to make a pattern like small number minus a large number, or large number minus a smaller number. Read and visualize. So let's plug into the equation. I have release. What does the word release mean? It is negative. So then your Q is equal to negative 2,500. And that's why it's important to understand loss in energy is negative, gain in energy is positive. So in this case, it's release, so that means it's negative. And your M is what? Well, in this case, your M is your mass. Well, we are looking for M. And that's why we had to put in M right there. What about your specific heat capacity, which is C? In this case, it is 0.138, okay? And lastly, our delta T. Again, final minus initial, so it's 20.0 minus 150.0. Now, all we have to do is simplify this. Can I simplify this using a Google calculator? Yes, let's plug this in. So let's plug in our calculator to simplify this side. In this case, I'm going to use parentheses again, 0.138. And notice how I use the parentheses again. And this gives me M times negative 17.94. Notice I haven't rounded the number yet. Try to keep 3 decimal places at least. So for this box, determine the sign for Q. Of course, Q is negative because it's release energy. Now let's plug in our answer for the next steps. Well, negative Q, and we know what Q is, so we have negative 2,500 equal to M. We are looking for M, so we just put the variable there. 0.138, that is our C, times the delta T, which in this case is 20.0 minus 150.0. And then we have simplified it. This turned out to be 17.94 equal to negative 2500, the same thing before. To solve for this, we have to divide both sides by 17.94. That would simplify equal to 1. If we divide that side by that number, we would do the same thing in this case, negative 17.94. And a negative divided by negative gives us a positive answer, okay? Which makes sense. Our mass is positive. You cannot have a negative mass. So let's plug this into a calculator. Negative 2520 divided by negative 17.94. And our answer is 139.35 grams. So we have 139.35 grams. And that would be our answer.